I'm going to show you two more examples of how you can use log properties to solve exponential equations, and we're going to do so with numbers that do not look super friendly but are super helpful. Going back to the bean counting situation, if you did not watch part one first, go watch part one first. Back to Gregoire and Fiona. Last video we worked on Fiona's models, or her model that she made to get to 100 and 1,000 beans. Now we're going to look at Gregoire's. The whole point of this was that the original question was who got to 100 or who got to 1,000 first, because we want to see like who would accumulate 100 beans first, and we predicted it was Gregoire. I predicted for you it was Gregoire because the base was bigger. That was the whole point of the last video. Let's take Gregoire's equation and actually calculate it. So I need to rewrite it again. G of t is equal to 0.972 1.629 t to the t power. Okay. Just like with Fiona, we want to find 100 beans. That means G of t is going to equal to 100. It means our y value is going to equal to 100. So let's set that 100 is equal to 0.972, 1.629. Remember, we purposely picked these awesome decimals because we can't do our pattern where we set the bases the same to solve for the exponents. So we're actually going to use our log properties. Let's divide both sides, 0.972, just like in the last video, 0.972. Oh, that's not what I want. Oh gosh, that awful clicking is here. Go away. Oh, I did it wrong. All right. Whoa, one, is that really right? Okay, 102.88. 102.88. Okay, 1.629 t. Okay, I had to check. Okay. Now we're going to take the log of both sides. Log. Oh, put the parentheses out here. Log. So now I'm going to do t is going to move down here to the front, and then I'm going to have log of 1.629. This is times maybe a bullet, and then log of 102.88. All right, so let's do this. Take the log, 2.012, and this is equal. Let's find out what log of this argument is. Oh no. Oh no. Come on. Okay. Log of, what was the number? 1.629 log 0.211. Now, how do I solve for t in this case? I'm just going to divide both sides by 0.211. 0.211. I'm going to get t is equal to, let's go back. I don't know what the last number is. 2. Okay. 9.49. T is equal to 9.49. So we need around 10 trials to get to 100. Gregoire needs 10 trials to get to 100 beans. I bet I beat him too. I feel like I accumulated really fast. Bonus points if you actually count how many beans I had. Keep paying very careful to that first part, that first clip. Okay, let's do this one last time, but instead of 100, let's do 1,000 beans is equal to 0.972, 1.629 to the t power. Let's solve this. I have to isolate b to the t power, so 0.972 divided by 0.972. Clear. Like 2 minutes to do this. 1,028.8. I'm sorry for not the right significant digits. 1.6. Oh, t. Oh, wait, what do I need? 1.629 to the t power. Great. I'm going to take the log. Log of both sides. log both sides. And I'm going to, this t is going to move to the front, which is awesome. Then I'm going to calculate this left-hand side. 3.012. And then this guy here, let's do, oh gosh, I need to move this. Oh gosh. Clear 1.629 log 0.211. Notice I'm not writing a million decimals. Some of you do that. You will talk about significant figures. I'm not very good at talking about significant figures. I was just did what I want. Not being a good scientist. Okay. I'm going to finish this off by solving for t. First times 3.012. 14. Oh, I think that's right. Yeah, 14.21. All right, so t is equal to, he probably got to, you can't have like 0.21 of a roll, so he had to get to 15 to get to at least 1,000. So trials. I think I beat Fiona and Gregoire. But I want you to summarize the main points of this video. The story of why we're counting this is coming up in class. So if you need to summarize just like who the characters are we're talking about and what they're doing, that isn't okay summaries. That isn't okay summaries. Okay, I'm going to go. My computer's going to die. Bye-bye. I need to get, how do I go? Be done. I want to end. Stop.